Welcome everybody. My name is Sean Huddy. I'm the Director of Strategic Partnerships with CERIAS. Welcome everybody in person and online. I'm going to do an introduction to our speaker today, Matthew Sharp. Matthew Sharp has dedicated over 2 decades to securing Unix and Linux servers across diverse environments of widely varying scale and complexity. In roles encompassing systems and network administration, red team contract work, and system and security. Presently, he serves as a principal engineer at Toyota Motor North America with their Cyber Defensive Services Group. His extensive experience has provided firsthand insights into the challenges associated with securing Linux systems in environments where Windows typically dominates both infrastructure and security investments. Sharp is particularly interested in practical, open source driven approaches to Linux security and fostering a mindset that empowers practitioners to take proactive steps in addressing problems that mainstream security tools often overlook. Today, he is speaking with us, and his talk title is Securing Linux in a Heterogeneous Enterprise Environment. So, Matt, please welcome.
Thank you. Thanks. It's an honor to be here, and I feel a little presumptuous giving a talk about Linux security where Eugene Spafford is, but we're going to do it anyway. Hopefully. Nope. All right. So I guess, yeah, who I am is Matt Sharp or Matthew Sharp or M&S or any number of things that I'll answer to. My role currently is that I'm a cybersecurity engineer focused on Linux security. My job description can roughly be summed up in one sentence, which is to improve the security of the on-premise Linux systems at Toyota Motor North America. So it kind of covers anything that isn't done already at Toyota regarding that, whether that's threat detection or like coming up with standards, adjusting patch policies, things like that. It covers all of that. My job is to just make improvements over time, which is an awesome thing to have as a job goal, because like if you have some leeway to do that, you can do a lot of things. My previous experience is largely in systems administration. I kind of fell into systems administration twice in a row and then realized that I should just go pro and move to California around 1999. I guess the first large or big deal systems administration job I got was with Marketocracy, which was a startup co-founded by Bruce Horn of original, like he wrote the Finder for the original Mac dev team at Apple. When I interviewed with him, I'm like, I can't not take this job, I'm moving. So I moved and started that job, and that company stayed in business for about 8 years. I was there for about 6 years. It was a great place to learn, but at some point I realized I needed to do something else because the company wasn't going to become super profitable like I had hoped it was. So I applied for a job at Apple in the Internet Services Group. Largely this is because when I was at Purdue, I had used first Dynix, and then they put the math science, in the math science basement, they built the Next Lab. So I got access to the Next Lab, started using NextStep. My first job out of school prior to all of these jobs was using NextStep and IRIX. Okay, I don't need to worry about that. Using NextStep and IRIX for that, and where was I going with this? I'm going backwards now. Oop.
Yeah, just tell me when you want to switch.
Okay, yeah, I guess go back one slide. The experience of working at Apple was a chance to see computing at scale. Like I thought that when I was at Marketocracy, we were managing 50 servers, that was a lot of servers. Suddenly at Apple, you're managing a few thousand servers, and every year that would double, right? Like, so the Internet Services Group at Apple was everything that was outward facing as a network service. So at first it was .Mac, and then that became MobileMe, and later iCloud. I'm gonna put that down. The Apple Store, the iTunes or the App Store, anything that was a network service would have been there. And every year we would double our footprint as far as hardware goes. So you start learning how to do things at scale, like you start implementing file integrity managing at scale rather than you manually going and checking the servers to make sure that nothing is wrong. So you start automating all that stuff, and then you start automating how you're going to provision systems. Like when I first started there, we were imaging systems manually, like going like machine to machine, putting a USB drive in, booting it, imaging it, et cetera. At the end, you've basically built the same parallel infrastructure to someone like AWS, where you spin up an instance with an API call, and 5 minutes later, the instance exists. From there, I left to try to become a police officer at age 45 because I'm not bright. I waited for a little while for that process to run its course. And during that time, did some red team contracting work and got trained up on physical security stuff as well. And then worked for a startup after that, then moved to the University of Texas System Administration Shared Information Services, and then applied for a job at Toyota. So everything from Apple on, when I started at Apple, it was OS 10 server and CERIAS. When I left Apple, that was hundreds of thousands of machines that are Linux, generally of one particular variant. Since then, I've used largely those variants of Linux, but have used those in server environments and tried to secure those as best I could. So this is about that, and I'm ready for the next slide. So what this isn't about, and I'm not going to read through all this, you are at Purdue, like ostensibly or presumably you would know about the book, right? Like the practical Unix and internet security that I'm sure you're all familiar with. If you want to know how to secure Linux anywhere, just read that book and do all the things in that book. It's largely these things. But we can go ahead and skip this slide because this is not about that. This is about the specific challenges of trying to improve Linux security when you don't have necessarily a larger footprint than the Windows infrastructure. There'll be a lot of Windows machines in your environment. There are therefore going to be a lot of Windows machines that are on fire security-wise, and your management is going to want to spend money and attention on those things because they see the fires where they don't necessarily want to spend the time on the Linux stuff because they don't see a problem. How to circumvent or navigate the impact of some of these challenges and how taking the initiative to build your own solutions, I would say, is not only a good idea, it's often the best idea. I also want to emphasize that the importance of like you should test and verify anything a commercial vendor says their product can do on Linux. Test and verify to the extent that you know the impact that thing would have. We'll get into the details of that later, I guess. And then how making the operations teams, the people who will actually make the changes that you want made, making them your allies is in your best interest and is literally the only way that you can achieve any of your goals. I'm ready for the next slide. So what do we mean by heterogeneous enterprise environment? So like I'm roughly dividing these into 4 groups of, and you can swap out Mac OS for Windows as necessary, but you basically have workstations that are Windows where there is a constant human user using that machine day in, day out. There are hopefully standard imaging and administration policies in place for that. The network connections for these are generally mobile. You can't predict, they're not going to be on a static IP. They're not at the same spot all the time. And they'll have multiple security tools on them. They are also the most frequently compromised systems. Like the reality of any given industry where you have a bunch of these systems is security sees a bunch of Windows incidents. They rarely see the Linux incidents. Those that do see the Linux incidents tend to be larger Linux shops, and they will often build tools themselves in-house that don't get turned into products for customers. So any given place you go will have their entire infrastructure that they built of security tools if they have enough Linux machines to have justified that expenditure. Windows servers, same thing. I guess on the Windows workstations, the blast radius for one server or for one compromised user or one compromised system is generally smaller than if a server is compromised. Sometimes that can pivot out, like if someone gets access to that and then can access data or other machines, that can be a problem, but your blast radius still is generally smaller when it's an individual that got compromised. Windows servers, same stuff that applies to the workstations also applies to the servers, except they will generally have a better network protection, right? Like they will be in a data center, they'll have static IPs, there'll be VLANs that define what they can and can't talk to. There will be firewall rules that say that this can or can't happen. So they get compromised less frequently, and the blast radius is a little bigger because servers are often used by at least multiple users, if not cascading services that rely on whatever service that server is running. So Linux workstations are rare. Like desktop Linux in an enterprise environment that is not doing something focused on Linux are rare, but they're not zero. So you will still have those, depending on how balanced the systems are, like how much Windows you have versus how much Linux you have. You may have varying levels of security controls, security monitoring tools on these systems. They are almost never compromised, and they have the same blast radius as a Windows workstation, except for regards to IP. Generally, the things that will be Linux workstations are there for a specific business purpose, and so you can lose some big information that you don't want to lose, where like an executive's laptop might not have the level of information that a research and design laptop has on it, right? And then finally, Linux servers are generally application or infrastructure servers. They provide critical services for the rest of the industry or the rest of your organization to use. Hopefully they're standardized in their imaging and administration. They see very rare human use, except for in development environments where you'll see a lot more. But in production or sub-prod environments for any given industry, the tendency of application teams is they will get the thing set up the way they want it and they will leave it alone. So you largely gain a lot of security just by having fewer humans using the system. The thing is, they also are exposed to other services or to the network, so there are other ways into these systems besides like SSHing in. That's when things go bad. So they're almost never compromised, and when they are compromised, it's horrible. Like you're bleeding money horrible. I am ready for the next slide. All right, so the specific challenges in this sort of environment for defending Linux are that your enterprise platform choices are going to define what you can and can't do, right? Like some things you are not going to be able to do because your entire infrastructure or your security group as a whole is using certain things, and you have to be compatible with that, or you have to work with that. Again, the attention and focus issue. When Windows incidents are all your management sees, then they want to spend the firefighting budget on the fires that they see. They don't want to spend firefighting budget on your hypothetical fires that you made up. So you have to kind of sell it. Like you have to remind people these are super critical. This is what we found so far. We need to watch these things. So that can sometimes be a struggle. Cross-platform tools. In fact, vendor tools in general often make promises about what their tools can do. And if you test them, they don't do those things. Another problem is they come up with hypothetical test cases for proving their functionality that are useless in an actual environment. So like I can find the iCar file or curls of the iCar file with a given tool named X, right? But no one's doing that, and I don't care. Like it's an iCar file, like big deal. I can catch that at the network layer. The key there is that you want to test and verify that it does what you want it to do and that it doesn't have an impact on the servers, which we'll kind of get to when we talk about the operations stuff. Linux servers are a pretty high priority target for attackers with skills. Like the attackers who have the motivation to attack a large organization are going to be more skilled than the average drive-by ransomware or criminal organizations who are just trying to catch some sort of profit. When you get larger as an organization, you have larger and more advanced attackers, right? Like the more valuable your organization is or your data is, the more attractive you are to a higher grade of criminal. Using the word loosely, but let's just call them criminals. And then finally, there can be a tendency in a lot of enterprise environments where they want to buy a commercial service, because that way they have a person on the other end of the line that's agreed to an SLA, and they can say, all right, your thing doesn't work. You need to fix it right now. That can sometimes be an impediment to solving the same problems with open source tools that maybe mean that you have to do a little work. You have to build some infrastructure. You have to put some code together in order to get it to work. The advantage to doing all that is it works and you own it, right? Like you can do whatever you want with it and you can tailor it to your needs. I'm ready for the next slide. Oh, sorry, another advantage is it costs less, but you're good. So I wanted to figure out a way to talk about the things by the various job functions that I do. And I sort of went through what I spend time on overall for a month-long period. 30% of my time I spend doing reconnaissance. And by reconnaissance, we'll get into what each one of these means in the following slides. 18% is research, 18% development, 21% is diplomacy, which is wherein I'm trying to convince someone else to do a thing. Or help them in some way in order to later get them to do a thing. Documentation, and then evangelism, which is also like gloom and doom, right? Like it's the opposite of evangelism because it's security. So you're scaring people into doing the right thing. That's part of your job. Ready for the next slide. So what do we mean by reconnaissance? Like in a Linux environment, the way you're going to find things going wrong are, one, you need to be aware of processes in your environment. You need to be aware of all the users in your environment. Like there's no, you need, network communications, services, and then infrastructure data, meaning like you need to know how authentication happens, what's in play in your environment. You need to know all the components that are in place and that you need to defend in order to know what is normal. And then you use what is normal to filter out what isn't normal. That's your problem, and you can address it that way, right? We're ready for the next slide. So what to do if you got this job today at a new company, say Acme company, right? And your job is now to secure or improve the security of the Linux systems at Acme company. Your first tasks, I'm largely defining as these. One, you need to figure out what exists now, what is in place in your environment that you can gather useful data from. You can determine the current existing state of like policies and like whether or not your systems are managed in a standardized way, whether they're imaged in a standardized way. If so, that's going to make your job a lot easier because you're going to have baselines that you can look at for that OS or for that system. You can expect that certain things are going to be the same across multiple systems. If they aren't, that's a sign that you can dig into. And it'll help you determine your blind spots and therefore what you need to work on as far as getting more data. I would also suggest getting test machines provisioned and get them with the lowest possible specs. Standard way, like don't ask for beefed up machines, don't ask for machines with special exemption from security policies. You want machines that you can test code that you're writing on the base minimum machines that are available from your org, because on the Linux side, that's probably how they got provisioned. Like somebody asks for 8 gig, they're going to get 4 gig. If somebody asks for 8 cores, they're getting 2 cores because your Linux just shut up and sit at the little table and color, right? Like historically, Linux sysadmins get no love until something's broken, and then they get blamed. And once they go back to everything being normal, they cease to exist anymore. That is your ideal life as a sysadmin. I'm not complaining about that. I did that for years, and you get used to it, and it's kind of nice. Like when things are quiet and everything's going great, you're great. You don't need attaboys. You just do the thing you need to do and keep moving. And then collect and consume the logs. Like I've seen arguments against centralization of syslog data, or not running syslog at all because it's not modern and disk costs money. Get more money. Like this doesn't cost that much money. You need the logs. Like you absolutely need the logs. The pro tip at the bottom, or sorry, I guess the one above it, become one with the logs. There's no way around this. Like if this is your job, you need to dig into the logs and look at the logs and learn what each thing is. And it's not even a months-long process. It's kind of a never-ending process because things will change over time. But you need to be abreast of what's going on in that environment. And the only way to do it is that. And the final thing is once you have syslog in place, as long as you have a method of executing code, you can use that as your notepad, right? Your syslog data is going to probably a data lake or something like that. If not, it's going directly into your SIEM. Either way, you can parse it in your SIEM, and if you write JSON output using the tools that you can expect on any given system, you could develop your own sensors that check for the security data that you want from those systems at whatever interval you want. Whether you're using a commercial product to run that, or you're using Ansible to run it on a schedule of these hosts at this interval, et cetera, all of that works great. And I am ready for the next slide. So research, by research, I guess what I generally mean is this would be either CVE research or vulnerability research. When something is announced, you need to determine what you have and whether or not you're vulnerable to it, or whether you're testing new solutions that might work for your, like research is kind of open-ended. It could be about any of these things, but a key element of this is define what you're doing before you start doing it. Define the scope of what you're doing. If you are not sure of what the problem you're trying to solve is, you will waste a lot of time. Know what you're doing ahead of time. Do that. Test everything meticulously. In fact, I would say build your own test metric software and test everything the same way. Collect that metrics and always rely on that metrics. Like the key for writing, and we'll kind of get to it in the development part, so I don't want to go too deep into it. But the key for that is that you want to have minimal impact on these servers because they are servers. You will burn bridges with the rest of the org if every time security suggests doing a thing, it ends up toppling somebody's server, right? Like that's no good. You want them to be your friends. They want the same thing you want. They don't want their systems compromised. You don't want their systems compromised. So don't accidentally make their server fall over because you didn't think something through. Don't run a find command on a base level file system when you have no idea which systems have like what NFS mounts on them. Like think about what you're doing, minimize the impact, and write efficient code. And then do read the documentation, particularly the internal documentation, because a lot of the times people don't read stuff and they can answer their own questions. By answering your own questions before you ask questions, which you should definitely ask questions to from the people who you need to ask questions of, but by answering your own questions as much as you can up front, you will build capital with them because they will be happy that you did not waste their time and you asked them an efficient question. I am ready. So development, and the first two are kind of the same thing. The bad news, of course, is that commercial tools for Linux security are often lacking. There are some that are great, but you will find oftentimes that Linux support for a given security tool was an afterthought on the behalf of the vendor who wrote it first for Windows, and then they wanted to be able to say it also runs on Linux. So they can ship this thing that compiles and it will run, but does it do what it's supposed to do? The vendor promises are vendor promises until you can confirm that it has the function that you think it has. Don't rely on the vendor's word on that. Don't rely on even third party, like they will send you recommendations like so-and-so uses it. I would like to see it work, just as a general rule. And the corollary to that is the good news is it doesn't really matter if these tools work because you can probably build what you need to get what you need now, using things that exist on each system or using infrastructure that you can, if you can write bash sensors that collect the data and then you could parse it somewhere else, then fine. Like you don't need JQ on every system. You can expect that bash is going to exist on any system. If audit control is there or audit D is there, then you can use AU report to pull that data. All this stuff is stuff you can build yourself. You don't need a commercial vendor. The bad news is you're going to own this thing. But the good news is it'll do exactly what you want. A simple solution is a solution that other people can someday manage without you. So like, if you build a thing that is so complicated that no one else can do this, that is now yours forever until you die or leave the company, in which case no one owns it, and then it becomes this ticking time bomb. Don't do that. Don't build ticking time bombs. Build things that can be handed off to other people and that they understand and can fix and do things with. And this is like the key one that comes from the systems operation thing, right? Like their systems administration experience. Thou shalt not have a substantial sustained impact on operations. You cannot sell to a bunch of people whose applications need to run on Linux that you need 30% of their CPU for 30 minutes at a time. That's not okay. Like your thresholds are going to be different dependent on your environment and how those applications perform. But like you never let the security tool get out of control, and don't approve tools being pushed that are going to get out of control, because the sysadmin life, like I was saying, is thankless, right? Like your job is bad. You're going to get no credit for the things you do right. You're going to get yelled at for anything anyone else does wrong. And don't make those people's lives harder. They're your friends. Make them their friends. Make them your friends by not impacting their stuff. And I already said to build your own test metrics code, use it consistently. And then the rules of writing Linux server security code: leave no trace, don't waste resources, and don't catch everything on fire, right? Like it's simple. Don't write a thing that leaves debris in the temp directory. Don't clean up your mess that you make when you're doing things. Don't suck up the CPU unnecessarily. Don't use inordinate amounts of RAM. And finally, never topple a system. If you just follow those 3 rules, at least no one will notice that you're doing things and everything will be cool. I am ready for the next slide. Diplomacy. So the diplomacy is as a sysadmin, I hated this part of this when I first started. The reality is it's super beneficial, but you want to look at the operations staff, whether that's network administrators, systems administrators, whoever. All of these people are your allies, and without them, you're not making any changes. Like you can, if you get the execution ability to write code and set code or execute code on servers, You can collect sensor information without anyone being upset about it. But once you start making configuration changes for them without them knowing about it, you're going to have problems. They're going to be upset about it. If like declarative configuration management is in place, it's going to have problems with it. Like, don't circumvent things to get things done that you want the operations staff to do. Make them aware of the fact that you want to do it, prove to them that it's not going to have impact, and have them do it, and at every opportunity befriend them. Like, gain their respect through competence, right? Like, again, it sounds like simple advice. Just don't ask, we shouldn't say don't ask stupid questions. If there's something that you can do in advance to look up what you need to know to ask the question, ask questions that are as informed as you possibly make them. So again, you're not just another task that popped up in their inbox from security that wants us to do a thing. Be clear and efficient in those communications. Oh, wait, I skipped that. All right, sorry, yeah. I guess that sort of speaks to the other one. Take initiative in learning about the environment on your own, and then in doubt, or when in doubt, ask informed questions. Be clear and efficient in your communications, and provide value to those teams when you build a tool that's monitoring their systems. Give them access to that tool. They also want to see that stuff. Like, they may not be the security operations center team or the incident response team, but they are definitely interested in the information that you have on their system. So share that information with them and help them with their products or their projects when they're trying to do things. And yeah, finally, I guess, be patient, right? Remember that, like, they're at the bottom of a hill that everyone pours nasty things down on, and they have an endless list of tasks from an endless list of people who have requested them. So don't pester them if they didn't get back to you within 30 minutes. Like, give them some time. Their operations, they work on things basically whether it's on fire now or it's on fire next. You don't try to escalate things because it's been 5 minutes and you want an answer now. Like, just be patient. They're doing real stuff. And I am ready for the next one. All right, so the documentation part is also a part, like, as a sysadmin, I see the value in the documenting everything you do, but it became a lot more apparent in the security role, where you may be the only one working on Linux security stuff. And so even the incident response team has no idea what to do if there's a Linux incident. And thus far, they've gotten away with that because there hasn't been a Linux incident. But be proactive with what you're documenting. Everything that you discover, everything that you test, everything that you build, put it in whatever documentation form is supposed to be how your company uses documentation, and put it there and sell it and hand it to people when they ask questions about it. Like, feel free to answer their questions, but also give them the documentation. They'll be super happy about it. Document everything you build, right? Like, document it so that if you get hit by a bus, someone knows what to do with the thing that you built or how it works. Documentation should also be a living document. So, like, everything changes all the time. It's really easy to not go back and update the documentation. Please go back and update the documentation. And share the documentation. That's kind of the same thing. Yeah, sorry, I guess the last one. Every single thing you document is one less silly question someone will talk themselves out of asking later. There's nothing worse than someone not getting an answer because they're afraid to ask the answer. So if it's as simple as asking, like, put the frequently asked questions about whatever it is you built in one place so that they can all read it and it all makes sense, and that'll save them the embarrassment of not knowing the thing. And it'll save you the time of having to answer the question 10,000 times over again, because you can just say, it's right here. This is the documentation. And I am ready for the next slide. I'm speed rolling this thing. The evangelism. So, like, a part of your role is, unfortunately, or fortunately, depending on how you look at it, telling people what you're doing. Like, if no one knows what you're doing, then they might have some need that they need to meet that includes something that you've been working on, and they may start building something themselves and wasting time doing something a second time, right? Like, just letting them know your thing exists can sometimes be enough. But they also may have methods or suggestions that might help the thing that you built. So show it to them, listen to feedback from them, work with them to build things that they need. And that sort of, yeah, I guess the other thing is sharing the information is also going to make your life easier. Like, if your security standards aren't just a Word document that you hand out to people when they ask for it, and they're instead in Confluence, and the ops, like the operations sysadmins have signed off on it and had some input to it, that's going to be more useful for everyone, right? They know what the overall goal is. They have some input to it. Yeah, I guess the part of me as a sysadmin that was against documentation or sharing the documentation was I wanted to reduce my interaction with human beings. Like, nothing against human beings, but when your life is getting beatings or getting nothing, you want nothing. So nothing means no one comes to you and asks you for anything. I had to kind of break free of that mindset when I went into security, where suddenly it becomes important to tell people about the thing you're doing or the thing you discovered, whatever it is. And yeah, the rest of it is a rehash of the first thing, really. So I am ready for the next slide. So my generalized mindset advice is broken down into these things. One is take the initiative to find work. And by find work, what I mean is you don't necessarily need to wait for someone to come and tell you we need this, right? Look around at the things that are not done that would improve your security situation now and start working towards those things. Chances are good no one's been working on it. It's up to you. So feel free to look around and you will always find something that is broken and needs to be fixed. Like, there's no shortage of that. I've worked with people in a variety of different places, and that propensity to try to find something to do, you're not finding busy work. What you're finding, sorry, more coffee. Oh, perfect. So the propensity to look around and find the things that need to be done is exactly what I'm going to look for if I was a hiring manager, right? Like, I want people who are going to proactively look around and find the things that need to be done. That may be a function of my age, because at this age, that's what I do in any place that I work. Like, I'm not going to wait for someone to tell me. I know what needs to be done, so I start doing it. But I would argue that all this generalized stuff about improving Linux security is straightforward enough that you can look around and see whether or not the logs are being forwarded, whether they're being parsed correctly, whether you're actually using them, whether you're collecting the additional security data that you need. If none of those things are done, congratulations, you found what you need to do. Like, that's the good news. The other good news is you're never going to run out of stuff to do. Like, there will always be more things. Always be more things. Don't be afraid to build your own tooling to provide basic security information you need, which I've kind of talked about. Stay interested in what you're doing by hands-on exploration whenever you can. Like, if you see a technology that might work in a particular situation that you're trying to solve in your environment, try it. Build a home lab, try that thing in the home lab, then try it on the servers that you have in your environment. It will keep you engaged in it, and it will keep you thinking of new things that you can do to put different pieces together to solve more complicated problems. Routinely put yourself in your organization's adversary's shoes to check your assumptions about your security posture. I would describe this as, and this is a habit I have at every job that I ever get, right? Like, the first thing I'm going to try to figure out is, if I was going to burn this place to the ground, what would I do to burn this place to the ground? In so doing that, you will find the holes that need to be fixed, because as soon as you find a way to burn it to the ground, now you know what you need to fix, if it can be fixed. And I wouldn't say, like, don't keep a notebook of how you're going to burn the place to the ground. You're just going to get fired. But be thinking about it from the perspective of who you think your adversaries. Like, if it's Toyota Motor North America, you're going to have a certain set of enemies. If it's this, you're going to have a certain number of people who are trying to attack you. Like, model based on what your org is or what they're doing. And then put yourself in the position of the person who's doing the bad thing and think, all right, this is what I would do, or this is what I would do. Come up with as many things that you would do that you find or can think of, and then you can address them any number of other ways. Don't assume the basics have been put into place. Like, with syslog forwarding is something I keep saying, and I would like to think that at this day and age, everyone does syslog forwarding by default, but I've been at 3 orgs of substantial size that were not doing it, and I oversaw the syslog centralization. Like, Apple wasn't doing it in 2006. That seemed insane to me, but it was the time, and by doing it, we had suddenly a pretty useful set of security data, in addition to performance data and other data you can get out of the syslog data. Don't wait for help. Don't wait for guidance. And really, that's kind of the first thing. Like, find work. Like, you know the principles that need to be applied. You can figure out what isn't done. Work towards those things. And next slide. All right, so this is more generalized strategic advice. It's not specific to these environments, but some of it is. And I've mentioned most of this before, but test any proposed solution thoroughly. Like you want to know the impact on CPU, you want to know the impact of, on CPU, on disk, on anything that is an environmental factor that will have an effect on servers that are running code that is why those servers exist. And you need to know also the behavior of the process that you're testing, right? You need to know how it behaves so that you can predict whether or not it's a good idea to do this thing. Prioritize your defensive and detection efforts based on the threat model for your organization, which is, again, think of who your enemies are, not your enemies, but like who are the people that are attacking your org? Like if you're a small 12-person operation, you probably don't have state actors attacking you. You never know, but you probably don't. So you don't need to model against that. You need to model against who are like inside a threat. Maybe it's, I don't know what it is. Like it depends on the environment, it depends on the organization, but base what you're defending on who your attackers are supposed to be. Basic detective work solves crimes. So again, the nation state sponsored 0 days are super exciting, but they almost never happen. Like mostly what happens are someone gets the ability to write code or write to a disk that shouldn't have happened. And then they figure out how to execute that code. And that's when the problems begin. And that's how you find something. Like a process name that is one character off from a normal process is not the same process. And when it pops up, that's a sign, right? Follow up those signs. And this is Linux specific, but YARA rules, sticks rules, and eBPF won't save you, right? Like they're great. Like I don't doubt that YARA rules and sticks rules work fantastic on the Windows side. I think a lot of that is because a good portion of the element that uses malware or does malicious things on the Windows side are not super bright. Like just like any average user, I don't mean that as a dismissive, like I'm not trying to get people to hack my home system by challenging them. I'm just saying that for any given swath of the population, you're going to have a top tier of people who have a high level of skills, and then you're going to have a huge amount of people who have regular level skills. A lot of the malware people or people who are using malware that they didn't even write oftentimes because they bought it from somebody in order to execute it on your systems. They don't have the ability, or they not thought that they can just change the file slightly and then therefore change the hash and circumvent the whole hash-based rule finding stuff. Like eBPF as well, it's not really a security tool. There are serious costs to using eBPF that the same people who will say you should use eBPF will also argue against Audit D for the reason that Audit D takes up too much CPU. Like, does it? You want me to use eBPF? Like, I've tested it. I know which one uses more CPU, so let's not do that. And I guess I already covered the hash thing. The operations is probably going to find compromises before you, because like they're the ones who get yelled at if anything goes wrong on the servers. Like if users can't get to a website, they're going to get a ticket that says internet is broken. Like if an application falls over, another ticket says application is broken. And they're going to have a whole like blame game going on for that, but they're going to find the things that went wrong probably before you. So again, work with them and learn from them. Some ideas that you have are going to be outside the scope of your role, right? So like I have a pet project or like a Don Quixote quest that I have to implement declarative, not package management, sorry, configuration management wherever possible. Like I think that it is a tool that is not generally targeted towards security, but its security value is huge. And I think the more you can convince your operations side to embrace something like Puppet or Chef or Ansible or whatever means of automating and enforcing condition and state of applications on systems, there will be huge security benefits. So if that's your idea to implement that, but it's outside your scope, talk to the team that is in the scope for and help them, like come up with securities case for why this is a good idea, support them. And finally, be versatile with your solutions. Like don't assume that everything you inherited today is going to be there tomorrow. Your seams changed, like your data infrastructure and the way your logs get forwarded and where they get forwarded, like where you store all that changes. The operations of the applications will change over time. Keep up to date with it and also make sure that whatever you write will still work with a different seam or with a different data flow. And I am ready for the next slide. Yeah, and that's it. Now I have if questions and answers. I have hopefully answers for any questions that you have. Fire away.
So you're talking a lot about like building your own tooling, but I'm like curious, do you have specific examples of like tools that you've built, security tools, or ones that you're like particularly proud of?
Um, for me, I guess like the one thing that it's a trick that I've used multiple times in multiple places is the determining what variables, like basically think of it from a command line perspective. If you were checking one system, what would you do on that system? And without installing any additional. So you can assume that you're going to have bash, you're going to have, if you have audit D, you're going to have, or you're going to have whatever tooling exists on all the systems, because hopefully they're standardized. And then figure out how to get the specific security information you want using those tools. And then use syslog forwarding to relay that to yourself by outputting it as JSON to syslog. In the process of doing that, you get structured data with exactly the data you want. And it's delivered at a, I'm going to say not a zero latency. Like it's not going to have zero latency. It's not going to be real time, but it's going to be closer to real time. And it's way closer to real time than the zero data you had before you did. So if that does that answer the question?
Well, I was just
Or you think more of other situations where you're not running code on servers to collect information, but you're using other tools to put tools. I think I just.
yeah, no, I think I'm a bit confused, sorry. Yeah, I was just thinking like because you mentioned like, oh, you have to have a lot of different tools that you build yourself from scratch. Like I was just curious of like examples of different ones that you built.
The things that I've built have largely been in batch.
Oh, it's just
using
bash
tools. Now, taking other people's tools, like I worked on a project that was it was geared towards manufacturing for devices that could not be monitored. Firewall.
Okay.
I worked on a system on chipboard that had Suricata running. And then we had multiple network interfaces, so you would pass through the data.
Okay.
And then it used like ADV Batman to like basically send the data back to the other machines that weren't on the network. But I didn't write that from scratch, right? I'm taking packages of things that work and putting them together in a system that uses those different things to do the functions that they're supposed to do. That
makes more sense.
Okay.
Yeah, I think I didn't understand your workflow.
Gotcha. It depends. Yeah, I guess I'm talking about vastly different things. Like sometimes I'm writing code that runs on all servers. Sometimes I'm writing code for a specific thing. Oftentimes what I'm doing is just gluing open source things together with pipes, right? Like if you could find a thing that works to do the thing you need, and you could fix a little bit of it to work a little bit better for you, that beats one, not having a solution at all, and two, trying to force something that doesn't really do it. Fire away.
All right. It's a question I've asked before to different people. How concerned are you as a security engineer about data that has already been harvested come Q day?
So it's concerned. How concerned I am? Like the reality is like you always had people putting data in places that it shouldn't be. In fact, a lot of the compromises, and I say a lot, there have not been a lot of Linux systems compromised on my watch. That's not because I'm good at what I do. That's because there have not been a lot of Linux systems compromised, period, compared to the number of Windows. But a percentage of those have been because someone put credentials in a CSV file and uploaded it to SharePoint or wherever they put it. Like it's still human error of letting data out that you didn't want. Now, you don't know it's out until you detect a new login from a place that you've never seen a login from, or until there are failed attempts, or like you really don't know, or you discover the data yourself and you're, oh yeah, that's not good. Like can we look back at SharePoint and see everyone who ever accessed this file? Maybe, probably not. I guess I would be impressed if you could. But the reality is once the data is out, it's gone. And that is, yeah, that's a big pile of dormant attacks waiting to happen. You don't know when you've been compromised because of that till they go active again.
How rough do you think is it going to get industry wide?
I don't know. It's job security, right? Anytime anything is built, it's going to be broken. I'm sure that someone will develop workarounds or mitigations for this, and then those will be broken. It's gonna be a perpetual cat and mouse game. And the more, like the higher the stakes, the more painful it's going to be. I think it's gonna get bad, but I don't think it's gonna be discernibly bad from. At least if they like it from the perspective of a security analyst who's on call. I don't think you're gonna notice that it's happening more frequently because you're just already there's constant inflare. Did that answer the question?
Yeah.
Okay. Sweet. If it's yes, fire away.
Mentioned that Windows like systems are compromised. So how do you feel about like virtualization as a solution to reduce the security impacts on?
Virtualization of this of the server layer, or like you're talking about using like ENC. Okay. Well, I think that most workloads in most enterprise environments are at this point are virtual. And like I should have mentioned it. This brings up the legacy systems thing, because be aware of legacy systems. But there are issues with like you basically have added an additional layer of things that could go wrong, right? The hypervisor is now something. And a lot of times the same theory is, well, we've never had a hypervisor get come. We're not going to worry about that, but probably worry about that. Fortunately for us, our systems, the hypervisors are generally hypervisors, so we are monitoring those as part of the pool of stuff we're monitoring. But they are different. They are, I mean, they handle things differently. They generate different alerts in an IDS. Like they're vastly different, and it does add another layer of like if someone compromises your hypervisor, now they own everything else on that thing. Lateral movement is move, right? You don't need to laterally move when you own the hypervisor. So potentially huge problems.
I've got a question
Right.
online.
Yeah.
It's from Ben, and the gist of it, he's asking about like maybe talk a little bit about anything you dealt with the attacks that are associated with like IoT.
So I have not dealt with them directly. Like I've not been on an incident response for any of that. The inherent problem that I see with IoT devices is that you can't necessarily, like, they don't follow all the other stuff that server pool does. They'll probably be on a different network. That network will be VLAN, and they're probably not forwarding syslog. They probably, maybe they're running your security stack, maybe they're not. It depends on whether the team set it up, bothered to check whether there was a security stack. Nothing about it. But even then, you have problems with them not being. Like if you're not getting syslog data for them, then how are you really monitoring? Run all the sensors you want. If you don't look at the data, then that's useless. And like you got to figure out some way to address that. It is an increasing problem. For me at Toyota, it's in somebody else's hands. So we've kind of divvied up. There isn't a Linux in manufacturing group or an IoT in manufacturing or Linux and IoT group. But there is an OT group, which is the manufacturing. They handle anything in that group. And then there's cloud security handles anything that's running in the cloud, which generally is Linux. They all try to apply the same standards, but depending on network topology, some of that may or may not just work with your structure. So sometimes you have to set up additional syslog collection points, set up additional configurations for these things, and enforce that for this case or that for this case. That answer that question?
Just got another one in. Let's see. It's from Sonia. It's a diplomatic question. How painful is it in the field to get those in charge of budgets to listen and apply the advice of the security team? And that kind of goes with what how hard was it for you to like roll your own stuff, I guess?
So it's going to depend entirely on the organization. Like I've been very lucky at Toyota. I have super smart management that I respect and listen, and like they are still pretty technical. If they hear me explain something and they have questions, they will ask questions until they understand it. And they have a much better job, or they do a much better job of big picture security management than I would ever do. I'm focused on. But depending on the org, it could be a big nightmare. Like I'm not going to name previous employers in particular. Not even gonna make up names that rhyme with those, but like, it can sometimes be a giant headache where they, well, why would I spend money on this? Well, why are you wasting all this time doing this? And because if any of this burns down, you don't have a business, right? Like, that's why. If somebody loses a laptop, you have one angry user. One angry user can be mitigated unless they're like buying you or something like that. If they're buying you, you've got bigger problems, good luck. If they're not buying you, one user will get over their anger in a couple of days, it'll be fine. But you can't just like network isolate your entire data center because something happened, like your business still needs to run, so. If you haven't addressed this stuff at an organizational level earlier before an incident happens, you're gonna have huge problems. For me, my advice would be don't work at that place. Like if you find a place that the management doesn't want to fix security problems before they become incidents, then they will later learn the hard way. It costs a lot more to fix things after things are broken than it does to fix them before they're broken.
Yep, Sonia says thank you.
Well,
It's time, you want to tell some stories?
I won't do it on the YouTubeable video.
Thank you.
Right, welcome.
We appreciate it.